Hello everyone, my name is Prasimir Kaur and in this video I'll be demonstrating my project Smart Cold Storage Monitoring and Maintenance System. In this project I have designed a cold storage monitoring system that ensures proper temperature maintenance inside a cold storage facility. The main goal of this system is to monitor the temperature and humidity in the real time automatically or manually control the cooling fan, trigger the alerts if the temperature rises beyond a threshold. This type of system is extremely useful in industries like food preservation, medicine storage, and agriculture warehouses, where maintaining ideal environmental conditions is critical. Now, let's talk about other hardware components and how they communicate. We are using Arduino board, Nano 33 IoT. This is the main sensing and control unit. It reads temperature and humidity using a DHT22 sensor and controls the cooling fan via a relay module. A buzzer is also connected to give sound alerts when temperature crosses the limit. Then Raspberry Pi acts as a central processing and data logging device. It runs Node-RED, which serves as both the dashboard interface and my MQTT broker client. The Raspberry Pi collects sensor data from the Arduino, pushes it to the Firebase, handles alert notification, and performs analytics such as average temperature, fan activity timeline, and etc. Then MQTT protocol we are using. This provides real time communication between the Arduino and Raspberry Pi. The Arduino publishes sensor readings and Node-RED running on the Pi subscribe to those topics. Similarly, when a user manually turns on or off the fan from the dashboard, Node-RED publishes that command back to the Arduino. Then we have Firebase real-time database that is used for data logging and historical analysis. The Raspberry Pi uploads temperature reading and alert event here, allowing visualization of long-term trends. Then we have Node dashboard which displays the real-time graphs, analytics, alerts, and manual controls. It provides a visual interface for monitoring and interacting with the system. This combination of hardware and software creates a complete IoT based smart cold storage system. Let's see how the system works. Let's see how the system works. First one is the data capture and communication. The Arduino reads the temperature and humidity values from the HT22 sensor. These readings are published via MQTT to the Hive MQ broker. The Raspberry Pi running Node-RED subscribes to these topics and displays the data on the dashboard. Next is the fan and buzzer control. When temperature crosses a threshold 25 degrees Celsius, the buzzer beeps for 5 seconds to alert the user. The fan can be controlled manually from the dashboard using on and off button. Automatic control logic is available, but currently we are more focused on manual control. We have used the automatic control logic for the fault tolerance here. Then we have data logging and analytics. Every few seconds, the Raspberry Pi logs temperature readings to the Firebase. Using Node-RED analytics nodes, the system generates fan activity timeline and alert summary. This helps in understanding when the fan is most active and when the temperature fluctuation occurs. Now I'll briefly explain the main functions used in the Arduino program. First is the setup Wi-Fi function which connects the Arduino board to the Wi-Fi network. It continuously attempts the connection until the successful and displays the local IP address. Then we have a callback function which handles the MQTT messages. Like the Node-RED sends on or off, the function receives it and triggers the fan control accordingly. Then we have the control fan function which actually switches the fan on or off using the relay. It also publishes the current fan status so that the dashboard always stays updated. Then we have a send alert function which publishes alert messages to specific MQTT topic whenever a fault or warning condition occurs. The main function reads sensor data, publishes readings to MQTT, handles buzzer beeping when temperature exceeds 25 degrees Celsius, and ensures the system reconnects if any disconnection occurs. Now let's have a look at the Node-RED dashboard. The dashboard has several components. First is the temperature and humidity display, which basically shows the real-time readings from the DHT22 sensor. Then we have a fan control switch, allows manual on or off control via MQTT. Then where there is an alert section which displays warning messages from the Arduino, and then we have some graph and analytics section where a real-time temperature graph is there and a fan activity timeline. All these are powered by data collected and managed through the Raspberry Pi, providing a smooth IoT dashboard experience. To make the system fault tolerant, we have used an automatic MQTT reconnection which ensures the data flow even if the connection temporarily drops. The Raspberry Pi maintains a backup log in Firebase so no data is lost if the device restarts. The manual override mechanism prevents unwanted fan toggling when the network commands are delayed. The buzzer gives a local physical alert, ensuring that even if internet connectivity fails, the user knows there's a problem. We also can add some possible improvements for adding automatic fan control with adaptive thresholds. We can integrate more sensor like CO2 or door sensor for comprehensive environmental monitoring, and we can also add AI based anomaly detection. To summarize, this project demonstrates a complete IoT based cold storage monitoring solution that connects Arduino, Raspberry Pi, MQTT, Node-RED, and Firebase in one ecosystem. It not only monitors real time temperature but also provides manual control, local alerts, and alerts on email as well, analytics, and data logging, all visible through a modern dashboard interface. Thank you.